in example 6, we're going to look at what happens when we try to determine the derivative and the domain of the derivative of a graph. So before, our derivatives were polynomials of other polynomials, so the domain was relatively the same, but now when we take the derivative, we end up with a denominator very similarly to when we use the quotient rule. So let's look at the derivative and its domain. So for example 6, f of x equals ln of x minus 3, and we want to determine and state the domain of f prime of x. So step 1 would seem like it would be to take the derivative, but for step 1 what we're going to do is actually determine the domain. So step 1 is we're going to determine the domain of f of x. So we have that f of x is equal to ln of x minus 3, and we all know that you can never take ln of a negative number, so then the domain for this is going to be x such that x is strictly greater than 3. This is because if you plug 3 or anything less than 3 and you're going to get 0 or a negative, which you cannot take a natural log of. So another way to write this would be 3 to infinity inside parentheses, which is interval notation. Okay, so step 2 is to determine f prime of x. So we want to determine f prime of x. So f of x is equal to ln of x minus 3. So f prime of x is equal to 1 divided by x minus 3 times the derivative of x minus 3. So we get f prime of x is equal to 1 divided by x minus 3 times 1. So f prime of x is 1 divided by x minus 3. So here I want to point out a couple things. The domain for f prime of x, if we were to just look at it, so I want you to, is every number except 3. So I want you to notice that the domain for f prime of x seems to be x such that x does not equal 3. That's what it would seem if we were just given that function. That's what we would determine. However, and this is important, the derivative does not exist where the function does not. So let me illustrate what I mean by this. Here is the graph of f of x equals ln of x minus 3, right here. So you see I can move this point across, and it keeps going this way to the right forever, but if I go less than 3, it disappears. It is not defined. See, it says right here, undefined. So keep in mind that the derivative is the slope of the tangent line. So here's the slope of the tangent line, and it exists pretty much everywhere, except when we become less than 3. It's undefined. It does not exist. So if I graph the derivative now, if I go ahead and graph the derivative, you can see right here it exists. Now, if I go back on your calculator, it's going to want to say, oh, well, the derivative is 1 over x minus 3, so it exists over here. But we need to keep in mind where the function exists and where the derivative does not. So if I just graph the derivative, it would look like this blue line right here. However, the derivative only exists on this side of 3. Okay, so the actual domain then for f prime of x is actually x such that x is strictly greater than 3. So I need to combine both the domains, which means I cannot include 3, and I have to be strictly greater than. Okay, so now what I want you to do is try this one on your own. So this problem says determine the derivative and the domain of the derivative for y equals log base 10 of the square root of x plus 1. Okay, so what we're going to do here, the very first thing we're going to do is determine the domain of our original function. So the domain of f of x is equal to, and again, it's under a square root, so we can not be negative, but also, since it's a logarithm, we also can't be 0. So the domain is x such that x is greater than negative 1. Not greater than or equal to, strictly greater than. Okay, so now let's take the derivative. F prime of x. Now remember, the derivative of a logarithm is 1 divided by whatever the inside piece is. So whatever this is, that's going to go right here. X plus 1 to the 1/2 times ln of the base. So ln of the base. ln of 10. But now what we need to do is we need to use the chain rule. So times the derivative of x plus 1 to the 1/2, because this piece right here was like an inside piece. So we take the derivative of that, and we get f prime of x is equal to 1 divided by x plus 1 to the 1/2 times ln of 10 times 1/2 x plus 1 to the negative 1/2. Okay? And we would do the chain rule again, but the derivative of x plus 1 is just 1. So now I'm going to go ahead and I'm going to simplify this a little bit. And I'm going to get 1 divided by x plus 1 to the 1/2 times ln of 10 times 1 over 2 x plus 1 to the 1/2. So notice that everything is being multiplied, and we have both of these with the same base. So I'm going to combine my like terms. Now if you have the same base, we add the exponents. So we get x plus 1 to the 1 times ln of 10, which is just 1 divided by x plus 1 times ln of 10. I forgot my 2's. Times 2. Okay? So just looking right at this, the domain of f prime of x is x such that x does not equal negative 1, because the denominator can't be 0. But remember that you need to find out where f of x is defined and where f prime of x is defined. So we have to combine the domain. So not only can we not be negative 1, but we also must be larger than negative 1. So from f of x, the domain was x such that x is greater than negative 1. And from f prime of x, we get x such that x cannot equal negative 1. So we have to combine those, and that's just going to be the domain of f prime of x is all x values such that x is greater than negative 1. And that's the answer. And that's not so bad.